Bismillahirrahmanirrahim. Assalamu alaikum and a very good afternoon to all. Today we are going to continue with the same chapter, behavior of metals, with a new unit, that is reactivity series. Okay, so we are comparing the metals for reactivity. Then we started with the competitive behavior of the metals. Today we are going to start with a new unit, reactivity series. Now to start this topic, let's first look what we did. We basically studied about some reactions of the metals with some elements of the periodic table. First, we analyzed the behavior. We did some reaction, practical, some experiments we did, and we mix a metal with the water. First we did this reaction, then we perform another reaction. Then what we did, okay, this was done, then some calcium and some sodium was placed inside the water, and we analyzed what is happening inside. Then what we did over here, we were analyzing, okay, what is the behavior of adding the metal inside the water, inside the cold water, and then in the steam water, and we give some conclusions, some inferences that what is happening by mixing this metal with the water. Then after this, what we did a reaction experiment. We did another experiment of a metal with the hydrogen chloride, and we found, like, we put some different metals, magnesium, zinc, iron, lead, copper, silver, gold, and we placed them in HCl, and we found, okay, whether the reaction is slow, vigorous, very fast. Then we added some acid, then we added some concentrated. We were analyzing whether reaction is happening or not, slow or fast, and we give the result of that experiment. Then after that, what we did, we said that these all are redox reaction. Then we did another type of experimentation. We studied some competitive behavior of the metals, like we mixed two type of metals into one another, and we burned them, we heated up. So what happened, we were finding whether these metals are replacing one another or not, whether they are more reactive from one another or not. Like as we did over here, we placed some magnesium oxide and carbon powder, so we were checking, okay, carbon is more reactive or magnesium is more reactive. In this crucible, what we did, we put a lead oxide and a carbon powder. So here we were analyzing, okay, whether lead is more reactive or a carbon is more reactive. Then we did some other reaction as well. Like you can see, okay, we were competing with other metals. As you know, here we have placed an iron, and we were analyzing with the copper oxide. So whether this iron will replace copper or not, we were checking this thing over here. Now over here, we were analyzing the competitive behavior of the metal, but inside the solution, in the iron state, we were checking whether which ion, copper or an iron, is more reactive inside the solution. So this was studied over here. This experimentation was done over here. From all these experiments and reactions of the metal with the water, with the HCl, of the metal with themselves, and we were checking the experiment inside the solution also. So we came to know, okay, the one which is more reactive, that is going to be placed first, that is going to be placed first, and this is what we call the reactivity series. So the results of the experiments in the last two units, now from those experiments, from the results of those experiments, now we can put the metals in a final order, like the one which is more reactive, very fast reactive, that we can place as on number one, and this is what we call reactivity series. Like from least reactive, then it is going to increase, the reactivity is going to increase, and this one is going to be the more reactive, the most reactive one. So in this is a reactivity series in which we have placed potassium, sodium, calcium, magnesium. This is from the first group, alkaline earth. This is from the third. This is the transition elements, and these you can see copper, silver, gold also are placed mixed in the transition and in the non-metal part. So what they are telling us, okay, these will be what will be least reactive, these are kind of in the middle, and these are the most reactive one. Okay, Okay, now you can see over here metals above the blue line, like above this blue line, above the carbon, aluminum, magnesium, calcium, sodium, potassium. What they will do, the blue line, carbon can't reduce their oxide, so the carbon won't be able to replace their oxides. It will remain as such, like no reaction will take place. If you react carbon with aluminum, carbon with magnesium, carbon with calcium, carbon with sodium, so it will not do any sort of a reaction. Like if you have a potassium oxide, if you have a sodium oxide, if you have a calcium oxide, magnesium oxide, aluminum oxide, and you react them with the carbon, so this carbon will not replace these elements with the oxygen, and you will have no reaction. You will have what? No reaction. You will have no reaction. Like if you have a magnesium, fine, and that is reacted with a carbon, so in the result magnesium oxide, fine, so you will have no reaction. If you have alumina, Al2O3 plus you reacted this with a carbon, so again you will have no reaction. So the metal above the blue line, carbon can't reduce their oxide. Now in this you can see the reactivity is a bit increasing, but then again they are saying okay, if you react hydrogen with lead oxide, like you have PbO2 and you have what? You have a hydrogen, so this will not do any sort of a reaction. You will not have any sort of reaction. Metals above the red line, they displace hydrogen from its acid. So yes, they will we won't have this oxide and hydrogen reaction, but what we have another type of reaction. Let me first write. Okay, we will have a pen. Okay, now let's suppose we have an acid. Let's have a look. I have a zinc chloride I have taken, fine, and that I am going to react with what? With H2O. So what will happen? As a result, zinc will be produced and HCl gas is going to be produced. So they are saying metals above the red line, they displace hydrogen from acids. So they are going to produce what? Acids from from zinc, iron, from lead, and these are the least reactive. They will not do any sort of reaction either with the hydrogen or with the carbon. They will be very unreactive in nature. They will exist as an elemental form. They will not non-reactive. What they are? They are non-reactive in nature. They will not participate in the experiment. They will not participate in the reaction. Okay, now over here you can see copper is used for roofing. Copper is used here in the roofing. Since it is unreactive, it do not take part in any sort of reaction, but over time it does form a coat of a blue-green copper 2 carbonate. So this green color which you can see, blue-green, this is basically a coating of the copper with a carbonate, and this happens with the time. Okay, now we have to move to the next slide, but before, Sir Hamza is going to explain the same slide.
Assalomu alaykum hurmatli o'quvchilar. Demak, bugun biz sizlar bilan o'tadigan darsimiz metallarning faolliklar qatori haqida. Demak, bugun biz sizlar bilan gaplashamiz. Metallarning aktivlik qatori ham deb aytishimiz mumkin. Demak, o'tgan darsimizda biz sizlar bilan ayrim metal birikmalarini uglerod bilan kimyoviy xossasini o'rganib chiqdik va o'sha o'rgangan paytimizda ayrim metallar o'sha uglerod bilan metal birikmalari uglerod bilan reaksiyaga kirishmasligini ko'rdik. Ayrim metallar esa uglerod bilan reaksiyaga kirisha olish xossasi haqida biz sizlar bilan gaplashgandik. Demak, biz metallarni aktivlik xususiyatiga ko'ra 3 ga ajratishimiz mumkin. Demak, dastlab birinchi turdagi metallarimiz bu kimyoviy faolligi yuqori bo'lgan metallar, ya'ni faol metallar. Bularga demak kaliy, natriy, kalsiy, magniy, alyuminiy kabi metallar kiradi. Bular demak boshqa metallarga nisbatan kimyoviy reaksiyaga juda oson kirishish xususiyatiga ega. Ikkinchi turdagi metallarimizga demak rux, temir, qo'rg'oshin kabi metallarni misol keltiryapmiz. Demak, bularning faolligi yuqoridagi kaliy, natriy, kalsiy, magniy, alyuminiyga nisbatan sustroq bo'ladi-yu, lekin mis, kumush, oltin metallariga nisbatan yuqori bo'ladi. Shuning uchun bu metallarni o'rtacha faollikka ega bo'lgan metallar deb qaraymiz va 3-turdagi metallarimiz passiv metallar. Passiv metallarimizga demak mis, kumush, oltin kabi metallarni misol keltiramiz va bular demak non-reaktiv, ya'ni faolligi deyarli yo'q bo'lgan metallar hisoblanadi. Demak, bu metallarning xossalari haqida aytib o'tadigan bo'lsak, masalan, faol metallar suv bilan osonlik bilan ta'sirlashadi. Suv bilan ta'sirlashish natijasida ular metal gidroksidi hamda vodorodni hosil qiladi. O'rta faol metallar esa suv bilan odatdagi sharoitda ta'sirlashmaydi. Ularni suv bilan ta'sirlashtirishimiz uchun demak yuqori harorat talab etiladi va bu reaksiya natijasida shu metallarni oksidlari hamda vodorod gazi ajralib chiqadi. Shu bilan birgalikda passiv metallarni suv bilan ta'sir haqida aytadigan bo'lsak, passiv metallar suv bilan ta'sirlashmaydi. Ularni qizdirganimizda ham yoki oddiy sharoitda ham mutlaqo reaksiyaga kirishmaydi. Shuning uchun ham bu metallarni tabiatda biz erkin holatda, ya'ni sof metal holatida ko'p ko'ramiz va ular bizning turmushda turli maqsadlarda ishlatiladi. Demak, mana bu rasmda ko'rsatib o'tilyapti. Mis metali o'sha binolarni qurishda demak mis qoplamalardan foydalanishimiz mumkin.
Okay, thank you, sir. Okay, now we are going to continue with the next slide. In the next slide, they are telling you about some important point to remember. The very first point is, let me take the highlighter. Okay, the very first point is the reactivity series is basically what? It's a list of metals, and they are placed in the order. They are placed in the order that give rise to what? To a positive ions. So in the reactivity series, the one metal which is more reactive, what it will do? It will do a reaction in the environment. How? It will always what? It will lose or gain electron. So whenever a metal, what a metal do? A metal always lose its electron and it's changed into a positive ion. Why? Because if it will lose electron, like if we talk about the sodium, so sodium is having how many? 11. So this will change into what? Sodium 10 by the loss of what? 1 electron. This 1 electron will give rise to what? It will look like a neon 10 and it will have a stable outer shell configuration. So the more easily its atom can give up electron, the one which can easily give its electron will be called as more reactive the metal is. Okay, the second point is a metal will react with a compound of a less reactive metal, for example an oxide or a salt in a solution, by pushing the less reactive metal out of the compound and taking its place. Let's have a look in a solution. Inside a solution, what I have a copper sulfate. I have a copper sulfate and I place an iron. This iron is made up of Fe. It is made up of Fe. So what it will do, this iron which is more reactive than the copper, so what it will do? It will replace. So FeSO4 will be formed and copper will be changed into elemental form. So the reaction has displaced the ions. So over here first I was having copper sulfate. Copper sulfate, and now what has happened? It has changed because iron was more reactive with the sulfate ion than the copper. So you can see, okay, so a metal will react with a compound. Now this metal has reacted with a compound. This is a compound. It has reacted with a compound, but with the less reactive metal, here the copper is less reactive. This is what? Less reactive. So that could be in the form of oxide or that could be in the form of a salt. Now here I have taken a salt of a copper sulfate. Now inside the solution, first I was having which color? Let me show you in the diagram, like as we did this reaction here, like here I was having copper sulfate, and what was the color of solution? Blue color. And here I have what? I have an iron. So now the solution is which color? Green color, and the copper is deposited on this plate. But in which color it is deposited? Let me first do it again. Now let me first this is blue. The copper blue is deposited over here. The copper blue is deposited on the nail. Now what we will say, we are going to check the reaction here in the same slide, what they are saying. Okay, now they are saying if you react a metal with a less reactive metal inside a salt or in the oxide form, what it will do, it will push the less reactive metal out of the compound and it will take its spirit, and it have taken its spirit. Now it is changing to FeSO4. Now the third point is, the more reactive the metal, the more stable its compound are. If the reaction is more reactive, so what it will do, it will lose and it will gain the charges, and as a result they will become more reactive, they will attract one another, and as a result a very stable compound is formed, and you cannot break them very easily. Then they will have a very strong attractive forces, Coulombic attractive force will be there. Number fourth point, the more reactive the metal, the more difficult it is to extract from its ores. If the metals are very reactive to one another, so it's very difficult to extract them from the ores in the unpure form, since these are very stable compounds. For the most reactive metal, you need the toughest method of extraction, which is electron. We have many methods of extraction, of digging out, of taking out that metal from any surface in the ore in the unpure form, but the one method which they have discussed, that is electrolysis. Lysis is a word for breaking. It is for what? For breaking. Lysis is a word for breaking. And electrolysis is for electric current. For what? Electric current. So with the help of a current we break that compound. Okay, in number fifth point, where is my pen? Okay, it's here, number fifth. The less reactive the metal, the less it likes to form compound. If the metal is unreactive, so it will not form any compound. That is why copper, silver, gold, all are found element in the earth crust. They are in uncombined form. The other metals are always found as a compound. Now Sir Hamza is going to explain the same slide, these points for the reactive metals.
Rahmat. Demak, metallarni faolliklar qatoridan biz ma'lum bir xulosalar chiqarishimiz mumkin ekan. Bu xulosalarning dastlabkisi, metal qanchalik o'sha faolliklar qatorida oldinda turadigan bo'lsa, demak u shunchalik stabil tashqi qobiqqa ega bo'ladi, o'z elektronlarini yo'qotish orqali. Masalan, o'sha faolliklar qatorida sodiumga e'tibor beradigan bo'lsak, demak u faol metallar qatorida turibdi va shuning uchun u o'z elektronlarini osonlik bilan yo'qotib, osonlik bilan demak tashqi 8 talik barqaror qobiqqa ega bo'lishi mumkin. Xo'p, keyingisi faolliklar qatorida demak faolligi past bo'lgan metallar birikmalaridan bu metallarni faolligi yuqori bo'lgan metallar siqib chiqarishi mumkin. Biz kechagi darsimizda sizlar bilan mis sulfatni temir bilan ta'sirlashishini ko'rib chiqqandik. Demak, shu joyda e'tibor beradigan bo'lsak, demak, mana temir metali o'rta faol metallar ichida turibdi. Mis metali esa passiv, faolligi past bo'lgan metallar ichida turibdi. Shunday ekan, misni birikmalaridan temir uni osonlik bilan siqib chiqara oladi. Ya'ni mis sulfat tuziga temir metalni ta'sir ettirgan paytimizda, kechagi darsimizda buni rasmini ham ko'rgandik. Ya'ni mana bu joyda mis sulfat tuzi eritmasiga temir mix tushirgan paytimizda o'sha temir metali misni uni birikmasidan siqib chiqarib temir sulfat va mis hosil bo'lganligini kuzatgandik. Demak, bu yerda o'sha eritma rangini o'zgarishi ham bizga o'sha temirni misga nisbatan faol ekanligini bildiradi. Keyingi xususiyat, uchinchi xususiyatga o'tamiz. Demak, faolligi, metallni faolligi qanchalik yuqori bo'lsa, u shunchalik barqaror kimyoviy birikmalar hosil qiladi va bu kimyoviy birikmalarni osonlik bilan parchalash mumkin emas deb aytilyapti. Faolligi past bo'lgan metallarda esa, demak, ularning birikmalari barqaror bo'lmaydi va ularni osonlik bilan turli birikmalarga parchalashimiz mumkinligi aytib o'tilyapti. Keyingisida faolligi yuqori bo'lgan metallarni ularning birikmalaridan ajratib olish qiyin. Buning sababi ularni birikmalari barqaror ekanligi va bunday metallarni ajratib olishimiz uchun odatda biz elektroliz usulidan foydalanamiz. O'zi metallarning olinishining 3 ta usuli bor. Birinchisi bu pirametallurgiya, gidrometallurgiya va elektrometallurgiya. Pirametallurgiya va gidrometallurgiya usulida o'rtacha faol va passiv metallarni ajratib olishimiz mumkin. Elektrometallurgiya, ya'ni elektroliz usulida faqatgina faol metallar ajratib olinadi. Boshqa yo'llar bilan ularni ajratib olishimiz mumkin emas. Lekin elektrometallurgiya yo'li bilan passiv va o'rtacha faol metallarni ham olishimiz mumkin. Xo'p. Keyingi xususiyat faolligi past bo'lgan metallar tabiatda erkin holatda uchrashi mumkin. Faolligi yuqori bo'lgan metallar esa tabiatda faqat birikmalar holida tarqalgan. Masalan, biz tabiatda kumush, oltin, mis kabi metallarni erkin holatda yombilar ko'rinishda uchratishimiz mumkin, lekin faolligi yuqori bo'lgan natriy, kaliy kabi metallar yoki temir kabi metallarni faqatgina birikma holatdagina tabiatda uchratishimiz mumkin. Buning sababi ularning o'sha kimyoviy faolligi. Kimyoviy faolligi past bo'lgan metallar erkin holatda uchraydi. Kimyoviy faolligi yuqori va o'rtacha bo'lgan metallar faqat birikmalar holida uchraydi.
Okay, thank you, sir. Okay, now we're going to further continue. Okay, over here they have given us something to remember, a very important point. You can see K metals we had to wait for. The reactive metals like the sodium and potassium, they are just invented by the process of electrolysis in 1800. Their discovery was done in 1800. Okay, let me first take the highlighter. This is a highlighter. Okay, the reactive metals, the sodium and potassium, they were invented and they were discovered in 1800 by the process of electrolysis, whereas the less reactive metals, like you can see the copper, that is widely used for 6,000 years, and iron was used about 3,500 years ago. Because they were less reactive, so they were not found in the they were easily being extracted out from the ores, but these were very reactive and it was very difficult to remove out from their ores. So you can see over here there's another point in the picture. A metal's position in the reactivity series will give you a clues about its uses. Like this is the unreactive iron coil, and this is unreactive metals which are used in the coins. If the coins were made of the reactive metals, so what happened? Okay, they will be change and they will melt out in the atmosphere, and you will not have in the existence of these ions for a long time. And as you know, these coins are being used so excessively by the people, so we need to have these coins from an unreactive matter so that their shape and their structure should not get destroyed. Okay, now in the another slide we are comparing the stability of some metal compounds. We are basically studying the thermal decomposition, like breaking down the compounds, metal compounds with the temperature. What is thermal decomposition? It is breaking. Let me first take the red pen. Breaking of what? Of metal. Breaking of the metal compounds with what? With heat. With heat is called what? Thermal decomposition. It's called thermal decomposition. Now a reactive metal have more stable compounds. You know, okay, they have very stable compound. Will they break down easily? No, they will not break down easily. So we are basically, these are the compounds: carbonate, hydroxide, nitrate. Carbonate will have CO, 3 negative ion minus 2, hydroxide OH negative ion, and nitrate NO3 minus 1 charge will be. These are the compounds of carbonates, hydroxide and nitrate. First we have to do the effect of heat on the sodium compound. Here we have to study the effect of heat on the copper compounds. So first what we have to do, we have to take any sodium Na2CO3. This is the sodium carbonate. You can see this is a copper carbonate. So whenever we heat this sodium carbonate, when we provided heat to this sodium carbonate, so there was no reaction and it was in the unchanged form in the white compound. It was having the same white color. Now what we did, the copper carbonate is blue green compound. Okay, it easily readily break down into copper oxide and carbon dioxide gas was released. Now in a hydroxide, if we take any hydroxide of sodium hydroxide, and if you want to heat it, if you want to give a heat, so again there is no reaction and the sodium hydroxide will be in the same white compound. But if we take a copper hydroxide, this is having a pale blue compound and it readily changes to cupric oxide and a water molecule is released out. Now if we take a nitrate, now you can see sodium nitrate is taken. This is a white compound, and when we give some heat to it, when some heat is given to it, we change to sodium nitrite and oxygen is released. Here sodium copper nitrate is taken and it is changed into cupric oxide, nitrogen dioxide gas is released and oxygen gas is released. This nitrogen dioxide is having a brown, it's a brown gas. Now we have to move to the next slide. In the next slide we have to talk about the reaction of thermal decomposition. We are going to do some reactions. What we are going to do, we are going to do some reactions for thermal decomposition. Compounds of copper, the least reactive metal, breaks down easily, they are saying, and the compounds of sodium, they will not break down. So a lower a metal is it's in a reactivity series. What does it mean? Like when a metal is less reactive, when a metal is less reactive, so what will happen, the more readily its compound decompose when heated. Now you can see over here what we have. If a metal is made up of less reactive elements, so that compound is going to decompose when heat is going to be provided to it. Now if we talk about carbonate, but except of sodium carbonate, potassium carbonate, if we have sodium carbonate Na2CO3, fine, so that is not going to change into Na2O and what, carbon dioxide. This reaction will not happen because sodium carbonate and potassium carbonate are very strong, the bonding is very strong, so they will not form these compounds. So they are saying except the sodium and potassium carbonate, if you have magnesium carbonate, what if we have magnesium carbonate, so what will happen, that will decompose into oxide and carbon dioxide gas is going to be released. If you have a hydroxide, now but apart from sodium and potassium, if we have, let's suppose, magnesium hydroxide OH2, so what will happen, it will change into magnesium oxide and what else, and water molecule is released out. A water molecule is released out. So hydroxide, except of sodium potassium, if you have magnesium hydroxide, so it decomposed to oxide and a water molecule. Now if we talk about the nitrate, but apart from sodium and potassium, and if you want to decompose them, let's have a look. We have a copper NO3 and 2. So if we want to decompose, if we want to provide heat, so what will happen, it will change into cupric oxide, and along with the cupric oxide it will give us nitrogen dioxide and it will give us oxygen gas. So this is how, but the nitrates of sodium and potassium, they form what, nitrites and oxygen, and other nitrates will give you all these three products. Okay, now this was the end of this chapter. I hope so you have understood. This is your homework and you're going to send me in the PDF form on the Google class. Now Sir Hamza is going to explain you the same slide in Uzbek language.
Rahmat. Xo'p. Metallarni faol qatorda metallarni birikmalarini barqarorligi haqida demak biz hozir sizlar bilan gaplashamiz. Shu bilan birgalikda ularni termik parchalanishi haqida ham sizlar bilan gaplashib chiqamiz. Xullas, demak, bu yerda quyidagi qoida amal qiladi, ya'ni metal qanchalik faol bo'lsa, uning birikmalari shunchalik barqaror bo'ladi degan qoida bor va shu bilan birgalikda metal qanchalik passiv bo'ladigan bo'lsa, uning birikmalari shunchalik beqaror bo'ladi degan qoida asosida tushunishimiz kerak. Bu metallarning termik barqarorligini demak, faol metallarni birikmalariga to'xtalib o'tadigan bo'lsak, masalan, faol metallarning karbonatlari, gidroksidlari, nitratlari, shu bilan birgalikda passiv metallarning karbonatlari, gidroksidlari va nitratlarini termik barqarorligi haqida natriy va mis misolda ko'rib chiqamiz. Demak, natriy karbonati oq rangdagi birikma hisoblanadi. Biz uni qizdirgan paytimizda u parchalanmaydi, shunchaki o'zini agregat holatini qattiq holatdan suyuq holatga o'tkazadi. Buni parchalanmasligining sababi demak uning birikmasi barqaror bo'lganligi uchun. Endi passiv metal mis karbonatni oladigan bo'lsak, demak mis karbonatni biz qizdirgan paytimizda qora rangdagi mis 2 oksidi va karbonat angidrid gaziga parchalanib ketayotganligini ko'rishimiz mumkin. Demak, mana bu joyda bu reaksiya bizga yozib ko'rsatilyapti. Xo'p, gidroksidlari. Natriy gidroksidini qizdirgan paytimizda xuddi natriy karbonat singari bu ham parchalanmaydi, shunchaki u suyuq holatga o'tadi, ya'ni natriy gidroksid ham natriy karbonat singari barqaror. Mis gidroksidni oladigan bo'lsak, mis gidroksidni qizdirgan paytimizda u mis oksidi va suvga parchalanayotganligini ko'rishimiz mumkin. Xo'p, endi nitratlariga qaraydigan bo'lsak, natriy nitratni qizdirgan paytimizda u natriy nitridi va kislorodni hosil qiladi. Mis nitratni qizdirganimizda esa u mis oksidi, azot 4 oksidi va kislorod gazlarini hosil qiladi. Va bu azot 4 oksidi jigar rangli zaharli gaz hisoblanadi. Xo'p, yuqoridagi reaksiyalardan demak biz quyidagi umumiy qoidalarni chiqarishimiz mumkin. Demak, metal faollik qatorida qanchalik o'yinda turgan bo'lsa, demak uni birikmalari shunchalik osonlik bilan parchalanishi mumkin. Karbonatlar, natriy va kaliy karbonatlaridan tashqari barcha metallarni karbonatlari qizdirilgan paytda shu metalning oksidi va uglerod 4 oksidiga parchalanadi degan umumiy qoida kelyapti bu yerda. Xo'sh, gidroksidlari, natriy va kaliy gidroksididan tashqari qolgan metal gidroksidlari qizdirilgan vaqtda esa demak ular metal oksidi va suvga parchalanadi. Masalan, mana bu joyda mis magniy gidroksidni qizdirgan paytimizda magniy oksidi va suvga parchalanyapti. Xo'p, nitratlari, bu yerda ham o'sha natriy va kaliy nitratlardan tashqari boshqa metal nitratlarini qizdirgan paytimizda ular demak metal oksidi, azot 4 oksidi hamda kislorodga parchalanishi aytib o'tilyapti. Mana yuqorida demak mis nitratni mis oksidi, azot 4 oksidi va kislorodga parchalanish reaksiyasi bizga ko'rsatilyapti. Shu bilan birgalikda mana bu joyda yana ayrim ma'lumotlar aytildi sizlarga. Ya'ni faolligi past bo'lgan metallar insoniyatga qadimdan ma'lum metallar hisoblanadi. Masalan, misni odamzod demak 6000 yil avval, temirni 3500 yil avval kashf qilishgan. Faolligi yuqori bo'lgan metallar esa 19-asr boshlaridagina fanga ma'lum bo'ldi va bu metallar asosan o'sha elektroliz yo'li bilan uning turli birikmalaridan ajratib olingan. Xo'p, demak, uyga vazifamiz mavzuni oxirida demak sizlarga savollar berilgan. Demak, bu savollarga javob yozib, bizni Google Classroom'dagi emailimizga yuborishlaringizni so'raymiz va biz demak sizlar yuborgan javoblarni tekshirib, sizlarni baholab boryapmiz. Xo'p, bugungi darsimiz shundan iborat. Hurmatli o'quvchilar, xayr, salomat bo'linglar.